Swayam Prabha. Digital India. Educated India.
Good afternoon, all of you. We are going to discuss more on the concept of hedge ratio and minimum variance hedge ratio. Now let's start. Let me ask a question. What is what could be the definition of a hedge ratio? So if it is a ratio, means it has to be a numerator and it has to be a denominator. And what should be there in the denominator? Okay, let me give the definition. So the hedge ratio is a ratio which is calculated by number of futures contracts market. Let's say let's go back to our soy oil product to mitigate the price risk of underlying spot position for let's say 10 metric ton. Going to be the 10 metric ton, and the number or the amount of futures is going to be the numerator. So suppose if it is going to take, let's say, 9 metric ton worth of futures, 9. Now the next question, all of quite aware of. So if a consumer is short on asset by entering into a long futures contract. So consumer, unless he does something, he would be interested to enter into a long futures contract, or vice versa. On asset, he would be mitigating that risk by entering into a short futures contract. Hedge ratio is 1. So in the sense, if the denominator is size of the spot position is 10 metric ton, the numerator is also going to be 10 metric ton. As a define a hedge to be 1 to 1 hedge ratio. So the underlying of the futures position taken by the hedger. Now many times also optimal result to the hedger. When I am using the word, optimality can be defined. So when we are talking about the optimality, of the portfolio risk, that is a hedger who is, suppose, let's say, short on asset and goes for without the future contract, the the consumer has only future, the consumer has exposure to the underlying asset as well as to the futures contract. That means the consumers or the hedgers total futures position, only risk he is facing is the risk of the fluctuation the futures contract. The hedger is exposed to the volatility optimality of the futures contract. And when we are talking about the optimality, we have to find out such that the risk is minimized and the portfolio risk is minimized, not a minimized. It's a combination of the portfolio risk is. So that that position or that known as your minimum variance. Optimality leads to selection of a number of is going to give the lowest of the portfolio. Let's go to understanding of how this minimum can be achieved. So let me start with, suppose a producer who is long on underlying asset, he would be able to mitigate this risk by going in case of one hedge. So underlying equal to the amount of underlying futures position. But in case of a minimum variance hedged portfolio, find out X contract for every 1 unit of so let's represent this X unit as RH. If a consumer 1 unit of spot, he would like to mitigate that risk H unit of futures. Unit of spot position, so let's put it as a S, and this is your delta unit of futures position. H unit, let me rephrase, the 1 unit of spot is equal to S and H units of futures is going to be HF. Now let's say the producer owns 1 unit of spot asset and if for every unit of price increase in the spot asset, he is going to benefit delta S. So his benefit is going to delta S, delta S. And the producer is long on asset. He would mitigate the risk by going short on futures contract. So his total benefit from the both long on asset and short futures contract is to be delta S minus H delta F. Why are we saying minus? Because whenever the spot price will increase and future price increases, he will gain from the spot position and he will be incurring loss in the futures position. So his net payoff is going to be governed by delta S minus H delta F. So similarly, you can have for a consumer payoff or consumer benefit is going to be H delta F minus delta S. So if price increases, consumer is going to incur loss in the spot position. However, he is going to be gaining in the futures position. So his benefit or payoff from the price change is going to be governed by H delta F minus delta S. Now if this is going to be the daily payoff, let's say what is going to be the portfolio risk. This portfolio risk will be coming from portfolio risk from producer point of view, who has taken delta S minus H delta F. So the portfolio risk, let me put it as RP. Portfolio risk is going to be governed by sigma square delta S or sigma square P will be sigma square delta S plus H square sigma square delta F minus 2H covariance between delta S and delta F, or sigma square P, that is portfolio risk, is going to be delta square S plus H square delta square sigma square delta F minus 2H, and we know covariance between delta S and delta F can be represented as correlationship between delta S delta F and sigma delta S and sigma delta F. And when we are using the word this sigma square, this is the variance of the return of the underlying asset. Sigma square is the variance of the return of futures combination, and you have the how the both delta S and delta F is moving with each other. It is governed by the covariance factor. So this is our sigma square P. So now if we have to find out that combination of H, for which combination of H delta square P is going to be minimum, so we have to take the first derivative of this portfolio with respect to delta H and equate it to 0. So going by that, we will have 2H into sigma square delta F minus 2H will not be there, so correlationship between delta S delta F and sigma delta S and sigma delta F. So this will be equated to 0. So when we equate this one to 0, so this gives rise to 2h sigma square delta f is equal to 2 correlation between delta s delta f minus sigma delta s sigma delta f. So 2 cancels out. So h is going to be correlation between delta s delta f into sigma delta s sigma delta f by sigma square delta f. So sigma square delta f, sigma delta f, sigma square delta f cancels out. So h is nothing but correlation between delta s delta f and sigma of delta s by sigma delta f. So this is our, so depending upon the correlationship between the change in the spot price and change in the spot price, change in the spot price and change in the futures price into the standard deviation of change in the spot price divided by standard deviation of change in the futures price is going to give us the minimum variance hedge ratio. That is the value of h. Let's say we are going to get a value of 0.6. That means every 1 unit of asset a producer is owning, he must be using, or he should use 0.6 units of that underlying commodity for buying future or for taking futures position. Now let's take some real life example to find out how this h is exactly calculated. So now this is the formula as it is mentioned here. H minimum variance hedge ratio is nothing but the covariance of delta S by delta F divided by variance of delta F. So this is what we discussed just now, that is correlation R delta S delta F divided by delta sigma S by delta sigma F. Now let me give you this real life example. This particular Excel file shows you the this Excel file has got 3 worksheets. So we are just talking about the worksheet number 1. If you can see, if it is visible to you, this is the black paper May futures contract available from NMCE website, and this column F is the futures price and column I is the spot price. Based on the futures price and futures price and the spot price, we have calculated the delta. This delta is nothing but your F1 minus F0, F2 minus F1, so on and so forth. So delta futures is the change in futures price on a daily basis, that is tomorrow's futures price minus today's futures price. Similarly, delta spot has been calculated, and we just now discussed that minimum variance hedge ratio can be calculated with 3 components, that is the correlation between delta S delta F and standard deviation of delta spot divided by standard deviation of delta futures. So if I calculate this, so this particular correlation between the black paper delta spot and delta futures indicates 0.58, and standard deviation of spot delta spot is 576, standard deviation of delta futures is 958. Going by that calculation, you have your delta minimum variance hedge ratio is 0.35. That means every 1 kg of underlying a commodity producer or consumer is holding or interested to buy, he should enter into a futures contract for 0.35 kg. So if he is holding let's say 100 metric tons of black paper underlying. A producer is holding 100 metric tons. He can go ahead and buy futures contracts for 35 metric tons. Now let's take other example. Besides the black paper, I have also calculated the isabgol seed minimum variance hedge ratio. This is this particular information which is given in the red font. So you have a correlation is 0.734, delta futures is 91.08, delta spot is 124, and minimum variance hedge ratio is coming to practically 1.999. That means every 1 unit of isabgol spot position being held by a consumer or producer, consumer producers should take a futures position for the same quantum of underlying. So 100 kgs of isabgol should be price risk associated with 100 kgs of isabgol should be hedged by entering into futures contract for a quantum of 100 kg. So now let's go to another commodity, that is the third commodity, which is the raw jute. And in case of a raw jute, let me increase the font size. So if you see the raw jute, this raw jute is your correlation is 0.35, standard deviation of delta futures is 25.7, delta spot is 15.4, and it is minimum variance hedge ratio is 0.21. So 100 kgs of raw jute if a trader is holding, then he should be able to mitigate the risk by entering into 21 kgs of futures contract. So this is the minimum variance hedge ratio. Minimum variance hedge ratio can also be found out from graphically, that is through our ordinary regression method, that is known as your beta hedge. As you can see from the screen, beta hedge. So what is beta hedge? Beta hedge is in this particular regression, you have a delta spot change in the spot price is taken as the dependent variable, and change in the futures price is taken as the independent variable. And using a regression methodology, we find out what is the beta, and the beta is the minimum variance hedge ratio. In fact, these two minimum variance hedge ratio calculated using this above formula, and this formula gives the same result, because this is the beta represents the H. Now let's go back to our same Excel file. I'll show you how exactly the regression hedge ratio for black paper has been calculated. So please see this one. So you have a minimum variance hedge ratio using our formula method. We calculated 0.35, and this is your regression hedge ratio using a scatter plot. So this particular graph has been done using a scatter plot and adding a trend line. And when we add a trend line and scatter plot, what we get to see here is y equal to 0.351x plus 165.8. So this is what the 0.35x, and this x is your delta futures, y is your delta spot, and this 0.35 is your minimum variance hedge ratio. That is the coefficient of beta is the minimum variance hedge ratio. Now similarly, quickly I'll take you through the beta for the beta for the isabgol seed using our formula method. It is 0.999, and using your regression method also, if you can see from the equation, it is 0.999x, y equal to 0.99x plus 6.025. Similarly, for your raw jute, the beta is 0.21, and also in this particular equation y equal to 0.0207x, so which is same as your 0.2. We can find out the minimum hedge ratio, variance hedge ratio, by using the formula method or by using the regression method. Now, with respect to minimum variance hedge ratio, I would like to discuss little bit with a concept called coefficient of determination. I'm sure each of you have done what exactly is a coefficient of determination within a regression. So that is your R square. So R square measures the hedge effectiveness. So how do we define hedge effectiveness? Hedge effectiveness is the percentage reduction in price of the risk or the spot price volatility due to hedging as compared to outright spot price volatility. So how much volatility of the spot price has been mitigated by adding futures into the portfolio. So hedge effectiveness indicates that ratio. In fact, it is nothing but the square of the correlation coefficient between delta S and delta F. Let's go back to once again to our this particular Excel file. If you see, R square, that is coefficient of determination, is 0.341, and correlation is 0.58. 0.58. So if I just square it up, so if you see this one, so this to the power 2. So if you see this, it is nothing but your coefficient of determination. So what exactly this coefficient of determination explains? That how much variability of y, or that is the delta spot, has been able to be mitigated by adding the futures contract into the portfolio. Similarly, let's go to our other two contracts. For ESOP gold contracts, the R square is 0.538, and for your raw jute, R square is 0.119. Now I will end this session at this point of time by asking a question: can minimum variance hedge ratio be greater than 1? Please think it over, and we'll discuss this aspect, whether minimum variance hedge ratio can be greater than 1 or not, in the next session. So thank you all of you, and looking forward to meeting all of you once again in the next session.